Morning, guys. Today's webinar, we will be discussing Adroit 10 Smart UI expressions and as well as expressions for the GOT2000 GT Designer 3. Just a basic introduction to the concepts and how to use these functionalities and operations, and how to derive a expression. So this is part one of the expression series. So there will be future amendments and follow-ups and parts for this topic. The next topic, the next part will be on the 28th of June, which will be presented by Adroit SCADA. He will do the more advanced concepts. And today we'll be looking at basic concepts and theory, and also the user interface in that regard. Right, so the agenda. So we'll have a quick introduction of what's involved and what the points are and factors to consider from a mathematical and logical aspect. And then part one, as mentioned, that would be the Adroit SCADA part for the expressions. We will look at the introductions, operation, basic operators, definitions, the structure of the expression agent, the operation, some extra notes and theory examples. For the GOT2000 part, by our GTWorks 3, we will also be looking at the introduction on how to access these functions, the functionality, and some theoretical examples. Then after that, we'll have a quick practical demonstration, just how to access these functions and operations, and how to use the tools that's available for both Adroit and GTWorks 3. And then we'll have the list of abbreviations, acronyms, and nomenclature. So I'll show you guys where the resources are for this presentation, and then we'll be open to questions. Right. Okay, so introduction. Okay, so as mentioned, we'll look at the basic principles, the definitions, the operations of the expression equations of both platforms, the Adroit SCADA and the GTWorks HMI platforms. So both of them have expression handling capabilities. That is to give these HMIs extra intelligence and decision-making functionalities in a very simple format based on logical and mathematical operators. So the first part, 1A, we'll be looking at as the Adroit SCADA, and then from there we'll look at the GOT2000. Okay, so the available tools to compile your own expressions will also be given. You can work from that point onwards. Okay, on the Adroit side, the expression functionality comes in the form of the agent type, okay, which in many ways can be used and seen as a data type, okay, and then also the variables which you use inside of the expression for the expression agent will also determine the data type that's being used for your calculation. In GTWorks, on the other hand, the data type will be determined by your inputs and outputs types. So in that regard, these two platforms are similar in their expression handling. So expressions very useful for basic and advanced applications in plants and so on. Mainly they use logical and mathematical decision-making capabilities, but there are additional functions that can be used as well beyond those two platforms. Okay, so basically expressions can be seen as a link between mathematics and logic, and programming computation via syntax language. So it converts your variables in your plants and your requirements into a language which your SCADA and PLC and so on can understand and process. So that's where the expression comes in. Okay, so part one, Adroit expression agent. Right, so as you know, there are many agent types in Adroit SCADA. Expression agent is one of the more powerful advanced agents. It's mainly based on C programming language syntax, and it can be used in a nesting format, meaning that you can use the outputs of your expressions as inputs of other expressions and so on. You can also use the output of an expression as an input of the same expression. That is for iteration calculations and so on. There's a tip regarding that, and we'll get to that a bit later. But yes, both of these functionality is supported Adroit SCADA's expressions. So your basic agents, like your digital agents, your integer agents, real agents, analog agents, so on, they're very simplistic and passive, so very reactive. But sometimes you will need the SCADA to allow for more decision making and processing of data. So in that regard, Adroit has a couple of tools that you can use for this purpose. The one that we'll cover today will be the expression agent. So that would be like a logical, arithmetic, comparative, procedure-based operation. The recipe agent, that is more for batching purposes and sequential flowchart-based processing. And then a more advanced one would be your script agent, which uses VB and JavaScript-based syntax. So today we'll only look at the expression agent, but all three of these can provide additional intelligence to your SCADA. Right. So in light of the question of intelligence, a question that comes that pops up a lot is, okay, fine, I've got an expression agent and all these scripting agents and so on. Why would I need a PLC for decision making? So in theory, yes, HMI can do all the operations and calculations a PLC can, in theory. Okay, but practically, that's not so simple due to the hardware performance and capabilities to be used in a practical plant. Also, your PLC needs to drive your I/O. So from that regard, no, a PC or the HMI cannot replace a PLC. You will, in most cases, need both these components in a process for decision making. Although I would just want to add that it's recommended that the PLC handles most of the calculations and logical operations, as that's its primary function, whereas a HMI or a SCADA has got additional functions, and decision making is just a secondary function of those two tools. So your expression agent in Adroit, you can have up to 20 input variables per expression. Okay, and your output, each expression will have one output, which is your 99 B99 output. Okay, if you need more, then you can obviously, as mentioned, combine the expressions. You use another expression to link to the primary expression to expand your amount of IOs and outputs for nesting purposes. Okay, so let's look at the very basic operators that you will need to start compiling your own expressions in the plant. Not all of the logical and mathematical operators are equally valuable or equal in weight. They've got different amounts of capabilities and weights and usability and also practicality. So For decision-making purposes, we'll look at the ternary operators or conditional operators. Okay, so these will be the three main operators that we'll use for decision-making. Okay, so for if else, if then and else statements, you will use the question mark, which means then. You can use the colon mark as else statement. And then also important, you need to use brackets to prioritize the order of execution, okay, within the expression. It's important to know that both the platforms uses the BOTMAS principle, obviously, for mathematical calculations. And the brackets in this regard removes any ambiguity and any confusion in the mathematical formulas. So you can never add too many brackets. As long as you have a closing bracket for each opening bracket, then your calculation will be legal. So yeah, just keep that in mind for priority order execution. Right. So to look at the logical operators, so these will be operators that you'll use mainly for logical functions, like your logical OR, logical AND, and so on. So those two are very popular, the AND and OR, that is typically used. As for arithmetic options, operators, you will use your standard add, and subtract, and divide, and multiply symbols in your expression to compile your equation. Right. Then you've got your comparative functions. So in a non-formal sense, for understandability purposes, this will be the comparative functions and the explanations. Like on top, you will have a if two equations are equal to, and second one will be if two equations or variables are not equal to, and so on and so forth. So we've got a less than or equal to, greater than or equal to, less than or greater than. So these will be basic comparative functions that you use in your Adroit SCADA expression agent. Right, so to compile an expression from a mathematical point of view, you first need to understand the components of each of the expressions to combine them to provide the predefined outcome. So equations. So an equation is a statement of two mathematical values or expressions that can be equated to each other via an equal sign, meaning that you don't need to have a constant on either side. You can have mathematical expressions on either side of the equal sign. So that is the equation. A formula is a mathematical relationship or rule expressed in symbols. So in other words, variables. So these variables can have coefficients, meaning that there can be constants which is multiplied, and so on. But the output will always be an unknown a variable that needs to be calculated. So that's a formula. Okay. Now an expression. So that's a combination of symbols. Okay, which is combined according to the rules of your mathematical and logical logic functions. Okay, and also it can contain constants and variables. And as with formulas and equations, it will obviously have operations, and brackets, and punctuations, and so on. Okay, we'll have a diagram just to explain how these fit together in a holistic sense. So terms. So a term is any number or variable that is multiplied together. Okay. And they are separated by plus or minus signs. So let's keep that in mind. A variable. So a variable is a symbol that is either unknown, which needs to be calculated, or a quantity that changes the whole time. Okay. So that would be a variable, like a device which you will scan from a PLC, or a user entry that's required in a HMI or SCADA. So that would be a variable. A coefficient. So a coefficient is basically a weight that you multiply a variable with. So difference between coefficient and a term is that coefficient uses multiplication or division, whereas a term splits their terms with add or subtract. Okay. The operator. So the operator would be any mathematical or logical operation. So that is a symbol that represents that specific operation that is used in your expression. Okay, so based on those definitions, we can say that all formulas are equations, but not all equations are formulas. So expressions can represent all equations, and therefore they can be used for all formulas. So what that means is, if you've got a predefined formula, let's say for a circumference of a circle, or to calculate the flow rate based on system pressure in the plant, or so on. So that would be a formula. Okay. And obviously your equations, your expressions will be able to accommodate that type of calculation. Okay. Also important, both logical and mathematical expressions that can be accommodated with that agent. Okay. Your output of the expression is stored in your dot value, as with all other agent types. But additionally, you can also store it in V99 in that expression slot. So both of these are slots that's used for your outputs. Your inputs will be, your input slots will be from B01 to B20 for a standard expression. So as I mentioned, each expression has 20 inputs, 1 output, and you can use them in combination with other expressions to increase both inputs and outputs. Okay. Also important to note that you can combine an expression with both logical and mathematical equations in a single expression. And we'll have a couple of examples of that just to demonstrate this concept. So you don't have to split these two magisterial of calculations. So how does the expression agent know what data type we use based on logical or mathematical equations? That would be based on your variable data types, your inputs, V01 to your V20. So those data types determine the data type of your expression output. Right, so if you look at a standard expression here, okay, and if you look at the components of the expression. So if we look at each one of these components. So V99, as mentioned, so that is your expression output result. Okay, so that's where your calculation output will be stored. Your end result will always be stored in V99. Then the equality sign. So the moment you have the equality sign, now you have an equation or a formula. It's not the expression anymore. However, this part here will be your expression. So this will be the part which you will add in both your Adroit expression agent and your GTWorks GOT2000 operation. So this part here will be the part that you will add in the expression calculation window. Okay, so as mentioned, this will be a term, okay, the ones in the purple brackets, because it's separated by a minus. And inside of that term, there are 2 different terms as well. Okay, so we just need to distinguish between these components of the expression to avoid any miscalculations. But that's a constant for, so that is a value can never change. So that's a constant. And this is a coefficient. But the reason why it's a coefficient, because you are adding a weight to a variable, unknown variable. So it's like an amplifier, a weight. So that is what we call a coefficient. Then an unknown variable or a variable that changes will be represented as a V value or input. So VO2, that's a variable. For expression agents in both GOT and Adroit SCADA, it's important to note that the only unknown variable here would be V99. Anything within the expression agent cannot be unknown, but it can be changing. So VO2, it's not the unknown, but it's a changing variable. It can be changed either by the user operator or by a process in the plant, if you scan a value to VO2, or if you have another expression which writes a value to VO2 of this expression. So it is a continuously changing or changeable quantity. Right, so as mentioned, so this will be an operator. In this case, this will be a mathematical operator, multiplication. It should be an asterisk, but for demonstration, for clarity, we use a multiplication sign here. Right, and this entire unit here will be your equation or formula. Okay, so you can use either one of those. So everything with equation sign will be your, with equality sign will be your equation or your formula. And the part that we will be focusing on will be your expression part. Right. Now, in Adroit, in Smart UI, how do you access your agent, your expression agent? So in your project, you can open your configurator, and in your agent configurator window, you can just browse to expression type agent, and you can go to your tag, which you created, user created. If you edit it, you will see the window where you can start editing and adding your variables and testing your outputs. As mentioned, that you need to browse in a slot, agent slot in each one of these variables, which you need, and also you need to add the constants where you need that. So that will be added by the user. So this is typically where you'll access the expression agent. Okay, so if you have a closer look at the expression agent, how it works, here's an example of an expression window. So that part in the top there, that will be your V99 or your output of your expression. So that will be your result of the equation. Okay. So with this part on top here, this expression becomes an equation. Okay, so this will be your equation output or the result of your expression. These 20 blocks or windows, you can add your variables, which you will use in your expression area below. So your expression area will call the variables that's being used and being browsed in by the user, perform the calculation and store the value at the result at your V99 slot value slot. Yeah, that is the calculation user-defined expression. Important to note that not all your variables have to come from this variable block here. If you are using constants, you can add the constants here. If you're using coefficients, you can add the coefficients straight at your expression as well. And obviously, you can add both constants and coefficients and variables in these open storage blocks. Yeah. Then your evaluation. So this is quite important. What is the rate or periodically how fast must this calculation being performed? You can choose a trigger, which is usually recommended to perform the calculation, like a 1 second trigger or so on. Or you can add continuous, which means the calculation will be performed as soon as a variable changes. Any variable changes, the calculation is being performed. That is how the continuous functionality works. Although continuous, in another sense, would be it's continuously evaluating the expression. Which both of these explanations are exactly equal. It works out exactly the same. Then this display purposes, this is mostly for troubleshooting and testing purposes. Okay, so traditionally you'll have your names here, which is your variable names, your variable names, or your if you added constants, so on. You'll see it here. If you want to test your calculation, you can click on the values here, and then you can manually change your constants, coefficients, and your variables, and perform a calculation test and see if your V99 updates. So that is the function of the display evaluation and trigger tools you see here. Right. So how do you start the expression? How would you initiate an expression or test an expression? So the first step would be to add all your variables that you will use for your expression. As mentioned, it can be coefficients, it can be constants, it can be variables. If it's variables, it needs to be variables of the form of agent tags. So user-defined agent tags like analogs, Boolean, digital, real, integer, or another expression you can call into one of these variable slots here. So that would be the first step. Okay, so so your expression output, so this is where your output result will be stored, and this is where you will enter your expression. So whatever expression you enter here will reflect an output in this value slot here. Okay. So that would be the third step there. After you've done that, you need to test your expression with the calculate button and see how your value updates. Verify if the calculation is correct. Right. Then from there, you need to decide what is your calculation rate. You want it to be triggered or do you want it to be continuous? And if it is triggered, if you selected the triggered functionality, then you need to choose a trigger. So these triggers can be a variable that changes, or it can be a discrete, like a binary Boolean discrete trigger that can be added. So you can have a 1 second clock trigger, or you can have a scanned agent from a PLC that would trigger the calculation. Or you could add a system clock trigger. Depending what your application is, you can add a trigger that changes. Every change will perform a calculation. And obviously when you're done, it's okay. Okay, so from a testing and simulation point of view, so after you've finalized your expression calculation equation, you need to click on display values so that you can see the variables, the actual values of the variables, or obviously constants and coefficients, and verify if your calculation is valid for the output. And then you can obviously add values. In other words, manipulate the input values and see how the output changes accordingly. So how you can test this would be change the value, your variables, and click on the calculation button and see how your value slot updates accordingly. Okay. Then after you've done that, you can modify your expression if needed. If there's any changes to be done, and you can then obviously after you did the change, you have to repeat the process to make sure that the changes you've made are reflecting the desired outcome. Right, and then when you're done, you can just say okay, and then you're finished. Then this expression will be finished and complete. Okay. Right, so just to summarize what we've seen, so your other expression input variables can be constants or variables. In that sense, constants can be coefficients as well. Your outputs will always be a variable. because you're calculating the output. The reason being, you are performing calculation on a very specific type of equation, and in this case, it will be a formula, in which case you've got one variable to be calculated based on input variables. Now, in your slots that you need to browse the variables for, okay, so you can use different agents, so analog agent, digital agent, integer agent, real agent, and so on. And for each one of these agents, you'll need to select the slot. So will it be a value, raw value, engineering max, initial value, rate of change, etc. So it would be always your agent.slot format, which you will browse in if you have a variable that needs to be used in your expression. As I mentioned, if you're using the expression for iteration calculations, in other words, you will constantly update an output based on addition of variables or a change of variables on the same output. In other words, if your V99 of that same expression is part of your variables which you browsed in, then it would be recommended that you don't use the continuous abbreviation, because that can cause freezing in some cases if the infinite loop is created. And in such case, we recommend you use a trigger evaluation, a 1 second trigger and so on, to prevent the expression from getting stuck in a loop. Right. So if you look at the example, if you add the following V05, for instance, in the expression, what does that mean in your expression calculation? So in this case, it means that equate the output value, which is V99, to the value that's stored in V05. So if you have a tank level in V05, then your output of your expression will show the same tank level. Okay. So application usage for such type of equation would be to replicate values. Okay, so it might sound impractical, but yes, there are applications where replication is needed. We've seen a couple of those. Okay, so let's look at something more complex. So here we've got another expression which combines mathematical operations and logical operations, okay? But mainly logical operations, which we'll explain now, with conditional operations. So this type of format will typically be used for simple interlocking. Now, as I mentioned earlier, that interlocking is recommended for PLC systems, not for HMIs or SCADAs. Interlocking must be done via hardware for obvious reasons, because your SCADA is dependent on the PC, your firmware and software and so on. And if something goes wrong, operating system and so on, then the interlocking won't work, obviously. So for safety purposes, it's recommended that hardware interlocking is used. But for something that's merely for the viewing purposes or monitoring purposes or for formatting purposes, this type of format equation can be used. And for something that's not critical, like a critical safety system that has a big impact in the plant, then logically, yes, you can use this format as well. So let's look at the main components of this equation, this expression. So as I mentioned, that equal sign means if these two variables are equal to each other. So that's an if equal to. This will be your logical OR operation. This will be your then operation, and this will be your else operation. Okay, so the columns are else operation, the question marks are then operation, and you've got your logical ORs and your comparison operators that's being used. Okay, so if we interpret this equation, this expression for this equation, basically what it says is if your V01 variable is equal to 2, or if VO2 is equal to VO3, whatever is stored in there, this can be tank levels, this can be motor speeds, system pressures, flow rates, any variable that's used in field or a variable that's calculated in a PLC or so on. Then your output, in other words, V99 for that expression should be 0. Okay. If any of these conditions are not met, or if either of these conditions are not met, then you will have to turn on your V99 state. Okay. If you want to change that equation expression for instead of either to any, you will change this logical or to logical and, which is two and signs, which means that both these conditions must be met before you will turn off your output of your expression engine. So that's just something you can demonstrate or test. You can also test it practically as a demonstration. Right. Another simple interlocking one. So here we do indeed use the ands instead of the ors. Another factor to consider is that instead of having a constant as outputs, we've got two equations at the end as two possibilities of variables as our answer. So in that regard, we can say that the expression agent can be used for equations as well, not only for formulas and so on. So there we have unknowns on both sides here. So your unknown output will be dependent on two variables that is continuously changing as well. So it's basically unknown dependent on continuously changeable variables. So if you just analyze this equation here, as I mentioned, brackets very important, not only for the calculation integrity, but also for the readability of the user. Remember, you can never add too many brackets, but you can add too little. So yes. And also remember that the number of brackets must always be a even number. You cannot have an odd number of brackets. Why is that? Because each closing bracket, each opening bracket must have a closing bracket. So that one's closing bracket is this one. This one's closing bracket is this one. So yeah. So let's interpret this equation. So if your value in VO1 is 1, and your value in VO2 is 1, and your value in VO3 is off, then your output will be the addition of VO4 and VO5. Okay. Otherwise, it will only be VO4. Okay. So that is the interpretation of this interlocking expression. So as I mentioned, this will be a logical AND. Right. So for next part, we'll have a look at GTWorks GOT2000 data expression operation. So there are a lot of similarities and there are a lot of differences as well. Basically, it comes down to the functionality of a SCADA versus the functionality of operating terminal, which there's a lot of overlapping functionality, but there's also exclusive functionality on either side. So, but we'll look at the common parts here in this presentation. Right. So the data expression operation GTWorks is a powerful tool that allows you to manipulate data in a variety of ways. As with the Adroit expression agent, you can use it to perform calculations, filter data, and to create data sets. Another very popular use for it would be to perform complex scaling. Complex scaling and capping of inputs and outputs, which the user will input or read from the PLC or towards the PLC. So that is a very common use for it. But yeah, as I said, there's a lot of other additional variety of ways to use this tool. So Adroit SCADA uses obviously your scanned or unscanned agent tags. So if it's scanned, it gets its value from the front-end device from the PLC. If it's unscanned, it's typically user-defined. So in other words, the operator can add a value based on the plant processes, and that would comprise the components of your expression. For the HMI side, these can also be constants and coefficients, but mainly it is devices that's used for calculation variable purposes. The three main types of variables that will be used will be your dollar signs, your $W and $G, depending on your application or the tag that you want to display, and so on. So yeah, so we can explain each one of these types of expression variables in detail in the following slide. So for dollar signs, that is a string. Okay. Now, important string obviously contains ASCII characters, but as I mentioned, important, it can also contain numerical values, like this, integer values and so on as part of the string. Just in some applications, a numerical value as a string cannot be used as part of a calculation, mathematical calculation, because it's not seen as a number, it's seen as an ASCII character. Okay, so in some applications you can do that, in some applications you can't. So if you are getting stuck in that and doesn't want to calculate, or you're getting a syntax error, I recommend that you use a variable or a number instead of a string. Okay. Then the $W, so that's basically a weight. Now, as I mentioned earlier on the Adroit side, that can be a coefficient for multiplication purposes and so on, amplification of a number, and division as well. Okay, so there's something to take in consideration. Both of these are displayed in word formats or double word formats, so can be used. Then the $V, so this will be typically your variable. So V here would be the same as VO1, VO2, etc. in your Adroit expression. So this will be just a V for your GT Designer expressions that you can use in that regard. Okay, so when you create a graphical interface on your HMI, okay, so you can assign different values to variables, and you can use them to for scaling and control purpose and display purpose and so on. Okay, so yeah, so easy to remember, V is a variable, and then obviously you've got your weight values for your and string values or other types of variables. Right, so how do you access the GTWorks expressions, data expressions? So first of all, if you want to change the output of a variable via an expression, so for that, that would be an advanced setting, and it will be a data operation setting, and then from there you'll access the data expression. And from here you can compile your data expression within that display value. So this will happen automatically in the background of your HMI program. So I just want to point out one important difference here in your GTWorks expressions. So here you have to select a predefined template for your expression and then add the operators, variables, constants, and coefficients in that predefined template for your output. Whereas with the Adroit expression agent, there's more freedom for the user to expand on its expression accordingly. And you can build your expression based on your C language syntax. Whereas for the GTWorks, it also uses a COBOL-like syntax, which you can modify. They are very similar, interchangeable in terms of the syntax, but based on this way these expressions are being performed, they need to be adjusted accordingly. So I just want to see. Okay, so these are the templates which we mentioned here that you need to select. Okay. From, and then obviously modify your variables or your constants or coefficients based on your requirements. So you can add quite complex scaling and modification to your tag. But as I mentioned, the Adroit expression side will provide a larger range of functionality and more freedom to express your expression for your own understanding purposes. So there's pros and cons on both sides of this application, and yeah, the user just need to use the tools that's available on either side. So if you look at the data expression, yeah, so this will be your end expression that you will have being displayed or entered by the user. Okay. And obviously, as mentioned, this will be your structures or your templates that you need to use. And if we look at the operators, so you can change the operators of your end expression based on your basic mathematical operators. And yeah, your coefficients, constants, and variables can be decided for each one of the variables. So obviously, the more variables you have, the longer this list. And obviously the data type can be determined. Okay, so here you can select the data type, whereas in Adroit side, the data type is automatically determined based on the variable inputs, data types. Right, so for your structure of your expression, so that would be your end result or your operating expression. This is where you will define your style of your expression, and these are the templates that can be used. This will be your operators, typical mathematical operators you can use in your expression, and their meaning. And if you look at your data types, so these will be the data types that's being used. Okay, hex or decimal or octal. Typically, decimal will be used for calculations of the process or the plant. Hex or octal can be used for data exchange between the GOT and other factory automation hardware like your VFDs or your servo amplifiers and PLCs and so on that requires a hex formatted or an octal formatted instruction to control the hardware via the GOT. Then for your expression itself, the variables of expression, coefficients and constants. So here you can see the range of terms that you can use, values that you can use, and so on and so forth. Okay, right. Now, if you have a closer look at an example of expression, especially from a display point of view, okay, not a write point of view, but a read point of view. So let's suppose that you want to cap the expression range, the value range via an expression. You will do this via the style range, and you'll then change your expression range that will cap your inputs from your PLC or the user or the field or any front-end device and so on. Okay, so this is also very important and popular, and it is mostly used in conjunction with scaling with this operation advanced setting expression. So if you use them together, then no mistakes can creep in terms of interpretation of values by the user. Yeah. So if you look at a simple theoretical example of scaling, for instance, so if we take the display value here and we fine, we want to take that display value and divide by 10. So that means that the value that you will see on the screen will be 10 times less than what is being displayed. Okay, so this is one example of scaling purposes. If you want something that's a more complex scaling, in this case for monitoring purposes, you can scale input from a PLC, say from 0 to 100 to 0 to 1200. And then this would be the expression that you will use for scaling of a value in GOT. Okay, so now you can do capping via scaling. So if you, as I demonstrated in the previous slide, here we have capping via scaling that will take value from 0 to 100 and cap it from -30 to 130, typically for RTD temperature calculations and so on. This can be used in the GOT. Right. Okay, so a more complex scaling. So once again, you can use it in conjunction with your style capping scaling, where we want to scale, for instance, a value from 0 to 100, let's say percentage-wise. Let's say you get a value from 0 to 100 percentage from a PLC. You can decode that value to give you a temperature value, for instance, from -30 to 90 degrees as a display output. So that is another option you can have in your GT Designer tree. Right. Okay, just some abbreviations, acronyms, nomenclature, just the explanation of what we had. I think we need to go now to the practical demonstration. So let me just open that. So let me just open Adroit as a practical demonstration. Right. So if you have a project ready and you want to, for instance, scale output value based on an input value, or you want to add some logical functionality to a output value, we can use the Adroit expression for that purpose. I'm just going to open the configurator here. So obviously you need to have variables for your calculation. So I'm just going to create some variables here. Yeah, so 3 variables, integers. You can have real variables as well for demonstration purposes. Let me just see. Yeah, that's fine. And let's say you've got some discrete inputs and outputs. So I'm just going to add a discrete output here. Okay, just to demonstrate how you will call these tag slots into your expression. Okay, so let's create an expression agent. And I'm going to give it a name, expression 1. Say, obviously you'll use the correct naming conventions for your plant. For instance, you will have your flow rates and system pressures and furnace temperatures and sirens and alarms and motor speeds and so on. But for a more generic explanation, I'm just creating these tags here. Right, so after we created this expression, obviously your variables which you created, which will be scanned in here, will be scanned in via a front-end device driver, PLC and so on, or it can be entered entered by the user. Okay, so let's suppose you've got output which is digital discrete that needs to be turned on or turned off. So we'll browse the output here. So out 1, say. So that would be your this variable, the agent type, will determine the data type to be used in your SCADA. Yeah. Then if we browse in, for instance, your integer values which we created, let's say flow rates and motor speeds and furnace temperatures, whatever the calculation may be. And we also add a real here. You can have analogs or another expression for nesting purposes. Then you add it here. You can fill these expressions up, these slots for the variables. You can fill them up. As long as all the expressions you use here, the variables you use here are used, that's fine. But if you have variables here which is not used in your expression, that's also fine. So you won't get an issue with that type of expression. So units, we can say it's on off, for instance. Using unit there. So if we make an expression, let's say we want to compare integer 1 and integer 2 of each other. So if your integer 1 is equal to integer 2 times integer 3, or should I say variable 3, okay. Now, important, each opening bracket must have a closing bracket. Then I want the output to be on. I want to start a pump. Otherwise, the pump must always be off. Okay. So there's an expression. However, syntax is very important. So you can press calculate, and if you get an error here, then obviously you will need to fix this. So if I can try to force an error in this expression here, then if I can use an illegal calculation, it should give you an error. Seems like all these ones I test are legal. Let's see. Okay. But if you get the illegal, if you add an illegal expression here, a little window will pop up when you say calculate. That will tell you, listen, this is a illegal calculation. Please change that. Okay. So if we add values now to the variables here, so if we perform this calculation, you'll see the output is 0. Why is the output 0? Because this equation is not met. This expression is not met. So if we say that, okay, for VO2 is 22 and VO3 is 2, and you do a calculation, then you'll see the output turns on. Because 22 times 2 is 44. Okay. So if for some reason VO1 changes, then your output changes accordingly. Okay, so this expression will work in the back end of your Adroit platform. So you can then simply change values here. So I'm just going to see here. So this will be display value integer 1. Just going to add a value here. I'm just going to okay, and I want the operator to change this value. Data entry, yes. Right. And then I want to also show the output. Or in fact, let me just create a digital, let's make it color, because it's binary. I'm going to give it a digital state color, green. And this will be my either my expression output or my digital agent output 1. You can either use this output 1 value here, or you can use your expression 1 B99, which is your value. Yeah, so they will give you exactly the same output result. Yeah, so I'm just going to use that one for now. And yeah, that's fine. And if we go run here and we change this value, let's say 43 should change. Let's see, I changed the background color here. I should actually change the text color. Display value. No, we can use display value as well. It's going to use the digital output one value slots. Okay, display the value there. So obviously it'll be a 0 or a 1. And you see, I can have a color here. If you want to change the text color, see, so state that expression is correct. That's fine. So here, let's just test this. Okay, so red means obviously it's off now. If you change 43, change to 44, it means the equation will be equal. Just let me see what expression is not running. I think I didn't save the agent server. Trigger. Oh, so I didn't add a trigger yet. So I'm just going to add continuous, which means the calculation will continuously perform in the background. Right, save changes. Let's see if it works now. So 43 should be red. Yeah, and we make it 44. Should be green on, one big on. So in the background, this expression is being performed and calculated. For testing purposes, you can keep your display open, and then you can just obviously play around with your values and see how it reacts and so forth. Okay. So this is typically how you compile an expression agent on the Adroit side. If we look at the GT Designer 3 that GOT2000 expressions here. So for this, I'll use it in conjunction with GXWorks3, the PLC demonstration. So if we have a value here, and this value will display the value that's in register D200 of your PLC. So in other words, in your D200 register in your PLC. So whatever value you display here will be displayed in your numerical display of the stack here. But also we want the user to be able to modify this value within a PLC and also provide scaling in the process. So for demonstration purposes, yeah, we have this one here. So I want the both display and the writing to the PLC to have the same expression. So what we have here is a expression which I selected on this template. So obviously you can modify based on the requirements here. Let's say I'm using this one there just to change text up a bit. And the first operator, I don't want a multiplication anymore. I want the addition, and second operator there, I want a multiplication. That's fine. Then for B, which is your second constant, let's keep it 0.5, and C, let's make this one 7, for instance, just to change it. And we want the display to be in decimal. Okay. So what we'll have here now is, if I can just update my simulator. Right. So what we have here is we've got this 16, which is the value which is read from the PLC side. So if I put 100 here, then you will see that it will display the value here. However, per our formula which we had, this 100 actually represents 16 after it's been scaled. So this can also work backwards. So if we enter a value here, let's say 12. So applying that formula, which we had in the data operation, this value changes and it writes that change to the same register in the PLC and it changes to 15. Okay. So this is how you would use the data expression agent in your GT designer tree. Just something that we need to skip something here. 6200. No, that's fine. Yeah, this looks good. Okay, so this is a simple demonstration of how to access the functionality of the expressions in the GT designer side. Okay. So for reference resources, because obviously we just scraped the surface here, these are the free references which I recommend, which you can attain all of this information and so on and so forth. From the Adroit SCADA side, a very powerful resource, we can find a lot of examples and also all the legal operators that you can use. So if you open your expression agent and you need assistance in this, you can just open your app file here, and then you can just go to your expression agent, and there's a lot of information here. But a good starting point would be your calculations and your examples. These two would be a very good starting point to see examples of how to compile and put together your own expression based on the requirements. So obviously, if you click on calculations, it's split into operators and functions. So here are all the operators you can use in your expression. The functions, so these are high-level mathematical functions we will use. And obviously the examples. So these examples you can replicate inside of your Adroit expression and test and modify accordingly. What they do, how they work, what these variables mean, what type of expression it is, all of them can be found here. So this is a very valuable, powerful resource on the Adroit side. From the GOT side, we have a manual. It's a designer. It's called a GT Designer Screen Design Manual. And this manual is approximately 4,000 pages. So it's a very good resource to have for your GOT2000 to access all of its functionality and use it as a search function. You can also use the e-manual viewer. Highly recommended. More interactive and more dynamic information can be found there via the search functionality. So yeah, we will expand on that. As I mentioned in the beginning of the presentation, this is only part one. This is the the introduction to basic concepts. The next presentation being presented by Aubrey Fasaki. He will touch on more advanced functionality of expressions. And that will be part two of this expression series. But do we have any questions? You can also add your questions in the chat as well. Okay, we've got a comment in the chat there. Yes, so this is true. So you can access all the examples of your expression agents if you click on our button inside of your expression agent itself. So if you click on the help button here, then it will open the expression examples here as well. So yeah, that's true. Okay, so obviously we have a couple of demos which we put together to demonstrate the functions and features of this webinar, which we will zip and email to anybody who needs it. So if anybody's interested for the presentation as well as the sample examples, just put your email address in the chat. If you don't want to, you can also email me via this email address, and I will send you the samples and presentation and more information if you need, if you require that. So we'll just wait 5 more minutes just to make sure that there's no questions. Please note that you can also direct your questions directly to me via the email you see on the screen. For more, if you want me to elaborate on specific points or provide additional resources. Okay, it seems like there are no questions. So yeah, then this would be the end of this webinar session. Thank you for attending, and we'll see you guys on the 28th of June for part 2. Thank you.